So today we are going to speak about Wi-Fi stuff. The idea is to present a few ideas about stuff, what we can do to achieve stuff in Wi-Fi. So it's more tips and tricks, a few tips, and I will try to do some demos so you will be able to see exactly what we are doing. So my name is Frank. We have been giving some talks on Wi-Fi at ShmooCon, at MoreCon, in different conferences. We have been working on Wi-Fi IDS, so all the Wi-Fi intrusion detection systems. And because we are very interested in this technology, we of course want to know if it's possible to bypass this kind of technology. So we have a few ideas in order to do things with Wi-Fi that will be very difficult to detect if you are using some Wi-Fi IDS. So beginning of this year, we have released 3 different tools, raw fake AP, raw glue AP, and raw covert. You will find more information on the URL. The main idea was to be able to use some specific Wi-Fi driver, and using monitor mode on Wi-Fi driver, we were able to do many things, like do some packet injection and fake many different systems, relying on the injection possibilities in monitor mode. Today we're going to speak about more stuff like this. We will release 2 tools to hide. The first tool, the idea is to hide access points and stations. We will release Mad Wi-Fi patches. And the second tool is some covert channel. It's the advanced tool, raw covert version 2, which is a new version. We already have presented raw covert 1 at ShmooCon. And the idea is to be able to build some covert channel on ACK frames, Wi-Fi very low-level ACK frames. So since a couple of years, it's the driver on Wi-Fi are much more flexible. It's possible to do many things, and of course the raw injection capabilities bring many possibilities. There are many drivers like Mad Wi-Fi, like Prism 54 or RealTelk, that will allow you to do some packet injection on Wi-Fi. The main problem when you are playing with Wi-Fi is that it still rely on the capabilities of the driver. For example, if you are playing with TCP/IP with Ethernet, usually it's very easy to do whatever you want, and you don't care about your network card. If you are playing with Wi-Fi, it's very important to know the kind of device you are using, because the capabilities are very different depending on the drivers. This is why we are using Mad Wi-Fi, because it's possible to use other drivers, but Mad Wi-Fi is quite easy to modify, and all the tools we have built are based on Mad Wi-Fi NG. So there are many possibilities to achieve stuff. We have decided to do some tweaks inside the 802.11 drivers to implement some kind of new proprietary protocol. And using this, I will try to show how easy it is to build some new networks that are very difficult to detect. And then we will introduce the covert channel on ACK frames. So if we look at the 802.11 standards, we have inside the 802.11 standards, there are physical and MAC layers. Of course, to be Wi-Fi compliant, you must comply to the 802.11 standards and follow all the requirements. The main idea is what would happen if we implement our own 802.11 stack, or do some very simple modification both on the access point and on the client. It could be quite fun because depending on the modification you are doing, you will still keep the good proprietary of the 802.11, meaning high performance and all these kind of things. But if you do some specific tweaks, we will be able to be really stealth. So this could be very funny. For example, let's think that you are not allowed to use Wi-Fi in your office. Some people, usually from the security people, will try to do some wire driving, try to detect rogue access point, fake access point. If you do some small modifications, small tweaks, maybe you will be able to use some access point, which is quite bad, of course, because it's forbidden by your company, but you will be able to use some access point, some client, and nobody will be able to detect it. So this is for the bad guy, but another possibility is to tweak your access point at home. You do some small modification, and then people just across the street, they are trying to wire drive, do some wire driving with that tool, and they won't be able to detect that you have an access point. So that maybe be useful to have your own access point and not be very easy. It will be difficult to detect. So we have been doing some modification on the Mad Wi-Fi driver, as I explained. We can do a very quick demo. Here, on this I have two laptops here. On my right, I have one laptop in master mode, which means that it's an access point running some tweaks Mad Wi-Fi driver, and this laptop is a client. So I can try to do some scanning on ATH0. It's my interface. And I'm able to detect different wireless network, Black Hat, ad hoc, this kind of network. So next, I will install my modify driver. Sorry. Just need to install the modify drivers here. There we go. So I still have my interfaces, my Wi-Fi interfaces. And I can do some and here you can see that there is only one cell detected, which is of course the specific access point, the modify access point. I can also, for example, try to run Kismet. And here you can see that even on this laptop, Kismet is not able to detect ATH1 network, which is the new modify access point. Kismet is relying on monitor mode, which means that it is able to analyze all the different packets that are detected on the wireless network, and of course is not able to detect our specific or modified access point. Here you can see that I'm connected to this access point, and I'm associated to ATH1. So what have I done to do this? Actually, we have done some what we call type tweaks. So if you look at the 802.11 header here, we have been doing some tweaks inside the frame control, so the header, and there are many things that we can do here in order to achieve some stuff. For example, playing with the protocol version. For example, playing with the type or the subtype. So in our example, we have done many tests. We have tried to test, for example, the protocol version. 802.11 is supposed to be protocol version 0. So we just say, now I'm using protocol version 1 on both the access point and the client. And this sometimes makes the detection very difficult. But we can do even more. For example, it's possible to do some swapping types. For example, inside 802.11, you have the management, the control, and the data frames. So in our example, for the ATH1 example, we have been swapping control and data frames, and we use some reserved value for the management frames. So in this case, even Kismet is not able to detect the network, and if you are running some sniffer, you will just detect something very strange on the network because you won't be able to recognize the different frames. Of course, it's also possible to play with the subtype. For example, you can swap probe response, probe request, clear to send, request to send. Possibilities are somehow very big, and you can really completely mess the protocol. So you will still be able to connect to your access point. The client and the access point will work together, but nobody else, if they don't know exactly the way it works, will be able to associate to the access point, or even to detect it. There are many possibilities, and if you want to go even further, there is a project called SoftMac, where it's possible to implement your own Mac layer with a Mad Wi-Fi driver, and here you can do whatever you want. The main problem is that if you do exactly what you want, there are some possibilities that it won't work at all, or you will have very bad performances, because using 802.11 makes sense. It works well. If you want to do your own protocol, it might be quite difficult. You will see this in the proceeding. Okay. Another possibility to achieve stealth communication is, for example, to use some kind of covert channel. This is what we also have done with a tool called Raw Covert, which is a Python tool. We are using two laptops. The interfaces are in monitor mode. And using raw injection, we are able to rely on ACK frames, which means very low-level packets, and exchange information between two laptops. The ACK frames are very difficult to detect. Usually, because it's very low-level Wi-Fi frames, people won't look at those frames. And so the cover channel will be very difficult to spot. The ACK frames, they don't have source address, and we are using the destination address to encode information about our cover channel. We are using a specific magic number in order to recognize the ACK frames that are part of our cover channel, and we have done the implementation using TuneTap inside Linux. It works quite well. The tool is available for download on our website. The URL is inside the presentation. I don't think I have enough time to make a demonstration. It's working pretty well, but there are many possibilities. For example, if you want to play with a covered channel, we can also try to use, for example, invalid frames, or play with the protocol. For example, something that could be very easy to do and very difficult to detect we can use some bad FCS frame, invalid FCS. FCS is the frame control, the frame check sequences, meaning that we using some specific injection capabilities, for example with Mad Wi-Fi, we are able to make some frames with bad checksum. And so if we know the kind of frame we are using, it means that usually IDS, Wi-Fi IDSs, or even people listening to the network won't be able to spot or to detect the invalid checksum frames, because usually on Wi-Fi that's something very common, so you don't take care about those frames. And you can use those frames to play with covered channel and do some communication between systems, being quite stealthy. What is also very nice if you try to play with invalid FCS frame is that many drivers won't even report that there are invalid FCS frames. So if you are not using this specific driver, you won't be able to detect those frames. This is a small ethereal capture of our covered channel, where you can see that we are using some ACK 802.11 frames. You can detect the magic number 0304. So all those packets are part of our covered channel, and then we encode the information, the data, in the end of the MAC address. Meaning that even you are not, if you listen for the network, you are not able to detect who sent the frames or who is receiving the frames, because they are broadcasted, of course, on Wi-Fi. So I will skip this part because for a 20-minute talk it's too long. Thanks for your attention. The tools, the patches will be available at this address, rfakp.tuxfamily.org. If you have any questions. Yes? It's possible. If you are, for example, if you are using monitor mode, you will be able to detect that there are some noise on the Wi-Fi network. But if you don't, if you spend enough time, you will of course be able to detect what is going on. So, for example, detect that we have there are some types swapped. But if you are using regular tools, even some war driving tools, usually the tool is sending probe request or trying to detect probe response, and of course you won't detect anything because we are not using this kind of types. So it's not advanced stuff. If you know what you're looking for, you are able to detect the network. But it can be quite efficient if you want to avoid IDS detection, if you want to avoid basic war driving tool. More questions? So thank you very much.